Hello student, how are you? I'm Arun sir. Welcome to my channel Tuition Expert. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the IIT exam and NEET exam confidently with a good rank. Today in this class I will teach you the free body diagram part 2. Now let's start about the class. In the previous class I have discussed the free body diagram. Suppose two blocks is present here and a force is applied this. Now the string, what is the tension of the string? I have discussed in previous class. Now there the mass of string tension at each point of the string is constant. That is, theory is that if mass of the string is negligible, there is light tension of string at everywhere is constant. Now if the mass is present, if you consider suppose this, and this is string of mass m1, this is a string of mass m2. Now the length of the string, what is the acceleration of whole system, and second question is about the find the tension of the string at a distance x. Suppose find the tension at this point. Find the tension of the string at this point. The acceleration of the whole system. We find first acceleration of the whole system. What is acceleration? A equal to F by total mass of the system. M1 plus M2 plus M3 plus M1 plus M2. This is the whole mass of the system. Now you find the acceleration. Now you have to find the tension of the string at this point. Draw the free body diagram. So this now whole system moves in this direction. So tension of the string is this and this. Now what is the mass of the system? This mass and this mass you have to calculate. What is the mass? Now take the mass per unit length is m1 by l1. Now this is distance x, so this mass is m1 l1 into x. Now what is the mass of the system? Mass of the string. This mass is m1 by l1 into total length is l1 minus x. This mass of this string is this, and mass of this part is this, and mass of this part is this. Okay. Now next, just acceleration. Whole system is acceleration. Put here. Now what is the force act on this system? This force is equal to T equal to m1 into a. This mass is this. This mass is this equal to m1 plus T equal to ma. So this is the equation of this part is this, and equation of this part is this. F minus T equal to m2 plus this part, mass of this part, that is m1 l1 x plus m2 plus m2 small. This equal to m into a. So if you add, then we get this. Now you have to find the tension of the string. So tension T equal to tension of this part at this point. So T equal to total mass is m1 into a T equal to ma. So put a A equal to what? A equal to F by total mass, m1 plus m2 plus m3 plus m1 plus m2. Now this is the acceleration at this point. So the problem is, so the theory is that if you take the mass of the string, then the tension are different at every point. Tension are different at every point of the string. Thick rope whose mass is m. Now the rope is pulled by force F. What is the contact force? Find contact force. Find contact force at this section. Find contact force. Now here solution is that here we have to draw the free body diagram. This and this free body diagram. So here force is F. This tension is T. So suppose this is the reaction force R and R. Now so write the equation of motion R equal to m into A, and here F minus R equal to m into A. So cancel F equal to A. So A equal to this. Now R equal to what? R equal to m into A. This is the answer. And the whole system is pulled apart with a force F. Now A and B. A is midpoint of rope. A is midpoint of rope. B is junction point. So find the point tension at point A and B. So this is the question. Now the whole system has moved upward with a force F. Now find the tension at A and B. A is the midpoint of the tension at B. For finding the tension at B, we have to draw the free body diagram like this way. This is M, small m. Now here we have to consider the weight. What is the different force acting on the body? Here weight of the body act vertically downward, that is mg, and here whole of the force mg, and a tension T and T. So this is the free body diagram of the system. The weight of the block is act through the center of mass, through the center of gravity, and here weight of the rope act through the center of gravity. Now at the junction point, tension act T, and in this section T. So this is the free body diagram. Now whole system suppose move vertically upward with acceleration A. So the free body diagram of this system will be F upward, T and mg downward. So resultant force is this equal to m into A. So this is the equation of motion of rope, and equation of motion of the block is T minus mg equal to m into A. First, so if we add, then T cancel, so F minus mg minus into A. So A is the tension. So this is the tension. Okay. For this system, we have to draw the free body diagram. Now here extra theory is that the weight of the each body act through the center of its gravity. Now if for finding the tension at A, here whole mass is, this mass is m by 2, because this is the middle part. So this is m by 2, and this is m. Now whole here we have to find the tension at here. So this is T, suppose T1, T. This is force F, A. Now we know the acceleration equal to total force F. Acceleration equal to what? Acceleration equal to F minus this force, m plus m into g divided by, this is the acceleration we know. Now here we write the equation of the motion, f upward and downward t1 equal to m by 2 into a. So t1 equal to f minus m by 2 a. What is a? A equal to this. First we find the acceleration of the whole system, f acting vertically upward, and here the tension of the string act, here weight mg, here m by 2g, here by 2g. Now what is the equation of the this system? T f vertically upward and t1 minus m by 2g equal to m by 2 into a. So this is the equation of motion of this upper part. So t1 equal to f minus m by 2g minus m by 2a. Now put acceleration at, so this is the answer. Two block the result. This is the result acceleration of the two block. This thing is different and this thing is different, so tension of each string will be different, but tension at each point, that string is light, so the tension at each point is same. Now this string is light, so tension at each point is same, but tension T1 and T2 will be different, okay, because these are two different strings. Now what is the, so question is find the tension of strings. Now the solution is that we have to draw the free body diagram. So here just cut this, we cut this. Now M1G act and tension T1. Now this is T1, this is T1, and this is T2, this is T2, and here mass M2G act and here M3G act. So this is M3G and this is M2G. That is weight of each block must act vertically downward through the center of its gravity. So M2G act and M3G act in this way. Now what is the equation of motion of block M1? This will be T1 minus M1G equal to M1A. This body moves with the acceleration A and this body moves downward with the acceleration A, the downward A. So each for whole system moves with same acceleration. So this is equation of motion of the block is T1 minus M1 equal to M1A. Equation of this motion of this block will be T2 greater, T2 plus M2G minus T1 will be M2A, and here M3G minus T2 equal to M3 into A. These are the equation. Now you add T2 cancel, so A equal to M3G plus M2G minus M1G equal to whole mass of the system into A. So A equal to this M3 plus M2 minus M1G by M1 plus M2 plus M3. That is M2 M3 will be added and M1 subtracted. Now for to remember this, suppose this is a block and here two block M1, M2 and M3, M4, M5 is present. So what is the acceleration of the whole system if the block moves in this way? This is downward and this is upward. Now what is the acceleration of the whole system? Acceleration of the whole system will be A equal to this plus this plus this, M3 plus M4 plus M5. This will be added and here M1 M2 will be subtracted. M1 M2 will be subtracted. That is M1 plus M2 by total mass of the whole system into g, obviously weight by total mass, m1 plus m2 plus m3 plus m4 plus m5. That is total mass of the whole system. So this will be added, this plus this minus this weight will be subtracted, divided by total mass of the system. This is the acceleration of the whole system. The next problem is these two blocks like this way, and A and B is rest on an inclined plane. Inclined plane is smooth, that is no friction is present. Find the acceleration of this block, find the acceleration of this block, and the acceleration of B relative to A. When the two system just release, immediately find the acceleration of the two blocks, that is block A and the acceleration of B relative to A. This is the problem. Now what is the solution of this problem? To find the solution, we have to draw block A is like this way, and block B is this way. Block B, this is block A. Block A is moving along this plane. What is the free body diagram? First the weight of the block MAG act vertically. Now weight of this block MBG. Now here a normal reaction act in this way. This is N, this is N. Now the block, this is the acceleration of along this way, acceleration of block in this way. Suppose this is A and the acceleration of block B is this along this direction AB. MBG minus N equal to MB into AB. This is the acceleration, this is the equation of motion of block B, and equation of this here N and MBAG act vertically downward. So component of this and this along this direction, what? N plus MAG of sine 30. This, so this and this act vertical along this, the component is this along the plane. We have already studied along inclined plane. Suppose this is a block, this is a theta. If mg act downward, then along this inclined plane force is mg sin theta, we have studied. So here extra n is added with this weight, so n plus mag into sin 30. This is the force equal to ma into aa, mass into acceleration. So these are the two equation. Now what is the relation between A and AB? What is the relation between A and AB? We have to find this relation between A and AB. Here acceleration of the block A is constant. This is no change. This is no change. So the part of the that is component of this part along this direction, this will be AB. So AB equal to actually AB equal to actually AA cos 60 degree. This is 30 degree, this was 30 degree, this is 90 degree, so this angle is 60 degree, this angle is 60 degree. Now the A is fixed, because plane is fixed, so we take that acceleration of the block A is fixed, and the component of the acceleration along this direction, this will be the acceleration of the block B. So AB equal to acceleration of block B will be AA cos 60 degree, because this part is cos 60 degree. So AB equal to A equal to 2AB. Now, so these are the free body diagram of the two block, and these are the equation of the motion of each block. Now if we find the acceleration of A and B each from the two equation, so put A equal to 2AB here. So what is the equation? Equation is mbg minus n equal to mb ab and n sin 30, that is n plus mag equal to sin 30 equal to half, so 2 ma a. Now what is a equal to 2 ab, so just put here, cancel this. Now we get a. What is a equal to 2ab, so 2ab, so this is equal to ab mb plus 4 ma. So we get ab, and also if we get ab then we get a. So this way we get the acceleration of a and b each. So this you understand this. Now the acceleration of a we get this, so the result is this, ab equal to mb plus ma g divided by this. This is the acceleration of the block, and if we put acceleration of the block here, a equal to 2 ab, twice of this, so a equal to twice of this. This is the acceleration. Now we get the acceleration of the block a, acceleration, that is absolute acceleration, that is if a person stand on the ground, then he count the acceleration of a and acceleration of block b ab this way. But we have to calculate the acceleration of b relative to a, that is if a person stand here, then at which acceleration the block b moves. So now let's it calculate. So a and this is ab. Now if we take the unit vector along I and this unit vector along j, if we take I is unit vector along x-axis and j is unit vector along this direction, so a relative acceleration of b with respect to a ba equal to actually ab vector minus a vector. So what is ab into j minus what is a act in this direction, this angle is theta, so 90 minus theta, this is theta, this is theta, so a equal to a cos theta I minus I plus a sin theta, a cos theta, a sin theta, this is theta, a sin theta j. So this is the relative acceleration of b with respect to a. So now cos theta I, now a sin theta will be ab. What is ab equal to a sin theta ab 90 minus theta, that is a sin theta, ab equal to a sin theta. Component of this along this will be ab, because a is fixed. Now the b moves with respect to a, so ab is fixed. Now we have to take the component of a along this equal to ab, not ab cos 90 minus theta equal to cos 90 minus theta not equal to a. We take a cos, because this is fixed, this is moved with respect to plane, this is fixed. So component of this along this will be ab. So this is right, this is not right, ab equal to a of cos 90 minus theta, not ab cos 90 minus theta equal to a. So you have to notice this. Now a sin theta equal to ab, so this part will be 0, plus a cos theta I. So aba, magnitude of aba equal to a cos theta, So this is the answer, relative acceleration of b with respect to a cos theta. Now what is the direction? If a man stand on the block a and observe the motion of the block b, then he plus I, that is in this direction. if a man stand on the block A and observe the motion of the block B, then he see that the block move in this direction, because the velocity, the acceleration vector is this direction, I, in this direction. Now next problem is that a rod, this is a rod of mass m is is held by two smooth walls. These are two smooth walls, remains always perpendicular to the surface of the wedge. This is a wedge and this rod is always perpendicular. This is 90 degree, always 90 degree. The mass of the wedge is this. Find the acceleration of the rod and that of the wedge. That is, the wedge moves in this direction, the wedge moves in this direction, and the rod moves in this direction relative to this. This is always relative to the wedge. Rod moves in this direction. Suppose A2 and acceleration of the rod is A1 in this direction, A1 A2. Now what is the relation between A and A2? And we have to draw the free body diagram, then we can find the acceleration A1 and A2. This is actual acceleration A1, this is A2. Now what is the relation between A and A2? Find. So this is A2, this is A2, and A1 is this, A1 is this along this direction. This is A1 and this is A2. This is A2, this is A2. So now here A2 is fixed, because A2 moves always in this direction. A2 is fixed. Now a component of A2 along this direction will be A1. So if this angle, this is alpha, and this angle is 90 degree, this angle is 90 degree, so this angle will be 90 minus alpha. Now A2 will be, A1 will be A2 of cos 90 minus alpha, which is A2 sin alpha. So A1, here A1 equal to A2 sin alpha, not A1 cos 90 minus alpha equal to, not equal to A2. Observe that which is fixed, A2, because A2 is always fixed, because A2 moves in this direction. This frame is always fixed, this frame is always fixed ground, and A2 moves in this direction. So we have to take the component of A2 along this equal to A1, not component of A1 along this is equal to A2, because this movement is relative to this. A1 is acceleration of A2 is fixed. So equation, and this is the rod, this is the rod of mass m, this is the alpha, angle alpha m. Now the wedge moves in this direction with A2 and the rod moves in this direction with A1. Now we have to find the relation between A1 A2 and different force act on the block. So the free body diagram of this will be, suppose this is N, normal relation N, so normal relation act in this also N. Now what is N? If this angle is alpha, then this angle is alpha, so this angle is 90 minus alpha, so component of this along this equal to N cos 90 minus alpha, that is N sin alpha. So equation of the motion of the wedge will be N sin alpha equal to M A2, that is N equal to M A2 by sin alpha. Now what is the equation of motion of the rod? Weight of the rod is act in this direction, normal N is along in this direction. Now component of this mg along this will be what is alpha? If this angle is alpha, then what angle is alpha? Then this angle is alpha, this is 90 minus alpha, and this is 90, so this is alpha. So mg cos alpha, so equation of motion of rod will be mg cos alpha minus n equal to m a1. A1 moves, the rod moves in this direction, Now what is the relation between A1 and A2? Wedge moves with respect to ground is fixed, so we have to take the component of A2 along this equal to A1. So that's why we take A2 sin alpha equal to A1. Now these are the two equations. So what we get equation, this 1, this is 2, and this is 3. If we solve 3 equation, we get a1 a2. Now what is, if n equal to this, if we add then cancel, so we get mg cos alpha equal to m a1 plus m a2 by sin alpha. Now what is the value of a1? So a1 equal to m a2 sin alpha this. So from this we get a2 equal to mg cos alpha sin alpha by m sin square alpha plus m. So this is a2, and if we put a2 here, we get a1. Square alpha divided by m sin square alpha plus m. So these are the two result, a1 and a2. Student, this is the end of the class today. To get such type of video and to continue this theory, subscribe my channel. Okay, thank you.